Okay, so I'm gonna go over the practice test here, test two. Well, test two, I don't know if that's what it's called, but unit two test, practice test. Let f be the function defined by f of x equals, and this should be the absolute value of x minus 2 for all x, which is the following. Okay, square root of absolute value. So one thing I know about this graph, well, okay, so I know that at 2 it's going to have a little, like a little, well, that's kind of like our central point, right? And then I know at 3 it's going to be 1. And then at 6 it's going to be 2. 3, 4, 5, 6. Okay, so at least on this end I know it would look like that. And then on the other end, 1, 2, 3, 1, 2, 3, negative 1, negative 3, 4, negative 2. Okay, there we go. So negative 2 minus 2 is negative 4. The absolute value of negative 4 is 4. Square root of 4 is 2. So there it is. So this is what we call a cusp. And I know that at a cusp, it is not diffy, right? It's not differentiable. Because that was one of the 3 different scenarios that we talked about, where it would be not differentiable. So I already know this is out. It's continuous. So this looks like our answer. It's not continuous, so it is continuous. The limit as x goes to 2 does equal 0, right? So that's true. And then it's not a vertical axis, so the answer has to be A. Okay. Number 2. All right. So if f is differentiable at x equals a, which of the following could be false? So I'm looking for a could be false situation. Now I remember that differentiability implies continuity. So if it's diffy, then it has to be yes, it is continuous. And that implication is very helpful for me with all this stuff, because continuity, there's 3 things, right? So f of a is defined. Limit as x goes to a of f of x exists. And then I know that they have to be equal to each other. Right? So these are my 3 conditions for continuity. And that is all of this business right here, right? Well, actually, that's not all. It's only 2 of them. But this right here is the limit definition of a derivative, right? And you know what? This one would be actually f prime of a, because of this right here, this here and that here, right? So f prime of a, and that's the very definition of differentiable. And then these 2 are basically interchangeable. And so my only last option here is that f double prime of a is defined. That one could, it could potentially be false. Okay, I'm trying to think what would be a good example of that. Yeah, I mean, nothing comes to mind off the top of my head, but by process of elimination, right, we're left with E as our answer. Yeah, I'm kind of thinking through a little bit here. Yeah, maybe, you know, I mean, if something should come, but the derivative of this can happen, and then the derivative of this doesn't necessarily have to happen. Okay, that's the idea. Okay, anyways, let's move on. Page 2. All right, so which of the following statements are true about f? So let's just go one by one. So the limit as x goes to 3 of f of x exists. So to do that with a piecewise, I need to check the left, and then I need to check the right, which is, from the left, it's x plus 2, right? So I'll just say 3 plus 2, which is 5. And then from the right, it's 4 times 3 minus 7, which is 5. So therefore, yes, it does exist. So 1 is good. So I can eliminate this, and then now it's down between 2 and 3. F is continuous. So this was the second part of that continuity theorem. The first part of it was that f of 3 is defined, and in this case it would be 3 plus 2, which is 5. So yes, it is defined. And then the third part being that they're equal to each other, and we can see that they are. Okay, so 2 is true as well. And then finally, to check number 3, so with a piecewise for differentiability, you want to take the derivative of the top and the bottom. So this one, the derivative of the top would be 1, the derivative of the bottom would be 4, and there's no x to plug it into, but we can see that they're not equal to each other, therefore it's not differentiable. So the answer would be D. Okay. Number 4. The graph of a function is f is shown above. At which value of x is f continuous but not differentiable? So let's look for all the continuous. So A, B, C, D, E. So it is continuous here, it is not continuous here, it is continuous here, not here, and it is here. Now notice this one it's smooth, this one it's smooth, so those are both differentiable. This one it's your cusp, so A would be the answer for number 4. Okay, number 5. For any function f, which of the following statements must be true? Must be true. So if f is defined at x equals a, then the limit has to exist at no. That's all continuity stuff, right? F is defined as just f of a, you know? If it's continuous, then the limit, absolutely. So this must be true because that's part of the continuity theorem. And then if it's differentiable, then this has to be true as well because differentiability implies continuity. So if it's diffy, it's continuous. So it just has to fall within that, you know, the logical order there. If it's differentiable, it's continuous. If it's continuous, then this has to be true. So 2 and 3 be your answer for that one, okay? Number 6 is very similar to what we just did. So remember for a piecewise, you want to take the derivative of the top, derivative of the bottom. So 3 and negative 2x. And then notice when I plug in negative 1 here, the top stays 3 because it's consistent. Negative 2 times negative 1 is 2. So 3 and 2 are not equal to each other. Therefore, it is not differentiable. Okay? All right, number 7. So this is a classic product rule. So first and second. So the derivative being first times derivative of the second plus the second times derivative of the first. So x times, and then I'm going to skip a step here, cos x plus sine x times 1. So that equals x cos x plus sine x. So where are you? There it is. Okay, B would be the answer. Okay, number 8 is a quotient rule. So first and second. So second times derivative of the first minus first times derivative of the second, all over second squared. 2x plus 3 times the derivative of the first, which is 3, minus 3x minus 2 times the derivative of the second, which is 2, all over 2x plus 3 quantity squared. All of these guys have that in their answer choices. 6x plus 9 minus 6x plus 4, 13 over 2x plus 3 squared. So it looks like D would be my answer to that one. Okay. All right, number 9. Okay, what is the value? Oops, I don't have answer choices here. Well, let's just find it. So f prime is equal to, so these are power rules, power and constant rules, so you just do them one at a time. So 6x squared minus 8x minus 0. F prime of negative 1 is 6 plus 8, 14. So there's my answer. So whatever option gives you 14, that would be the answer for that one. Number 10. Let's see here. Okay, so, you know, as I look at that, I can see that this is an f prime of c, and then this is an average rate of change. Right, so f of b minus f of a equals b minus a. There they are, right here and right here. So if I connect those two guys, this would be f of b minus f of a all over b minus a, or the average rate of change. Okay. Now the question is asking for how many values of c in this interval, so from a to b. So within this window here, how many times does f prime of c equal the average rate of change? Meaning, when is the instantaneous slope equal to the average slope? So we can see the average slope, it's slightly steep, right? Slightly positive. And so what I'm wondering is how many times does it equal that? And so if I go right around here, I can guess that it would probably be that, maybe here. Now here, nothing happens. I would say maybe here and here. So altogether, the answer should be 4 times. Okay, and so whatever answer choice gives you that would be the answer for that one. Okay, next one here. We're almost done with the multiple choice. Okay, so there's f of, oh my gosh, let's just type, there should be a minus here, there should be a minus here. So this right here is the formula f prime of pi over 4. So first I can find f prime of x, tangent is secant squared, and then I want to find f prime of pi over 4, which is secant squared and pi over 4, and before I even try to figure it out on my unit circle, I look at my answer choices, and there it is, right? So there's no point in working that out. All right, number 12. So let f be the function defined above. Which of the following statements about f are true? Okay, so f has a limit as x equals 2. So I think that should be a minus sign, but let me just, yeah, there should be a minus sign. Okay, so left and right. For this have to come from here, right? So when I put those in, I get 0 over 0. So this is I need to figure out what to do here, but I can do that, I can do that. There it is, and then when I put it in, I get 4 as my limit. So it does have a limit. Okay, so 1 is true. However, it is not continuous because this is 4, this is 1. Right? And then if it's not continuous, it's not differentiable. Right? If it's not continuous, it's not differentiable. That's like our first step, right? Right off the bat, if it's not continuous, it's not differentiable. I know that for sure. So the answer for this should be 1 only. Okay? All right, number 13. Which of the following functions are continuous at x equals 1? Just, I guess, an easy, quick way to do it is we can just plug in each of these. So if I say ln of 1, that would be 0. E to the 1, that would be e. Then ln of e minus 1 would be some kind of value here. And then as far as I can tell, there's no issues with continuity. Just even imagining the graph, right? At x equals 1, there's no type of break or asymptote or anything like that. I mean, this one I kind of thought it might be, but then it's e to the 1 minus 1, so that's still a number. So this is more like ln of like 1.71 or something like that. So that's okay. That's okay. So, so I would rule with that. Okay. Then number 14, the function f is continuous and close to 0, 2 has a values that are given in the equation of x equals 1/2. Must have at least 2 solutions in the interval 0, 2 if k equal. Okay, so I always like to graph them out just to make sure I know what's going on. So there's my 2 points. There's my interval. Now I don't know what's going on, but the equation f of x equals 1/2. So meaning the horizontal line must have at least if k equals. So if k, okay, so I see. So if it's 0, it would have 2. If it's 1/2, it would only have 1. And then these 3 guys are just above the line, so it doesn't really help. So the answer for that one would be A. All right, and then the final one. Okay, so let G of X. Okay, so this is my floor, this is my ceiling. So this looks like a squeeze theorem problem to me. What is the limit as x goes to 1 of f of x? Okay, so what I can do is I can find the limit as x goes to 1 of g of x, which is sine of pi over 2 plus 4, which is equal to 5, right? Because pi over 2 here is 0, 1. And I know that sine is equal, so this is 1. 1 plus 4 is 5. And then I can find my ceiling, which I betcha would also be 5, but let's just double check. Negative 1/4 x cubed plus 3/4 x plus 9/2. Negative 1/4 plus 3/4 plus 9 halves. 1 half plus 9 halves, 10 halves, 5. There we go. So since g of x is 5, h of x is 5, and I know that f of x has to come in between there, so 5, 5, 5. So there's number 15. All right, FRQ's in the next.